Welcome. I want to talk to you about dimensions or dimensions and measurements and how these relate to use, to materials and to context. And to do this, I want to start with this picture. It's a drawing by Eindhoven architect and artist John Kermeling. The person you see here is Napoleon, of course. Leonardo da Vinci, in his Vitruvian Man, stated that the height of the navel of a person above the ground related to the total height of this person. The ratio between these two is 1.62. So if your total height would be 1.62, your navel would be on a height of 1 meter. And John Kermeling speculates that Napoleon, being the French emperor or maybe the emperor of the whole world, took his own body as let's say the measure of all things. So the height of his navel above the ground should be the unit of measurement everybody should use. So the height of the navel of Napoleon being 1.62 meters, according to John Kermeling, the height of his navel is 1. So this became the meter. The meter the whole world is now using in the metric system. Napoleon is the measure of all things. And probably, Leonardo da Vinci also got this ratio from somewhere. Maybe some of you recognize this ratio, this fraction 1.62. It is the ratio of the golden section. And the golden section in mathematics, let's say, has a lot of very special properties. The golden section is the ratio between two measurements, a big one and a small one, and the ratio from the big one to the small one is the same as the sum of the two to the big one. So I hope I'm explaining this understandably. The small is to the big, like the big is to the sum of the two. And this golden ratio can be found in many figures. For example, in a pentagram, and also, and there are reasons for it, in many instances in nature. For example, in sunflowers. Once again, here it is expressed. To be exact, it's 1/2 plus 1/2 and the square root of 5, which equals more or less 1.62. Now, maybe John Kermeling, he's an artist, so I'm not sure Napoleon was exactly 1.62. I think it was a bit bigger. But this as a start of what I want to talk about. Let's say measurements, and maybe measurements related to the size of your body. I'll leave this space and go to another place. Okay, change of scenery. I don't know if you ever wondered about the thicknesses of boards, for example, plywood. Thinking about the back of these measurements, if I measure this, this is, for example, 3 millimeters. I go one step further, and this is 9. One step up, this is 12. One more, this is the standard thickness of plywood, you know probably, is 18. Strange. You would expect with this 1 meter or our centimeters or millimeters, you would expect thicknesses of 5 and 10, 15, 20 would be easier to calculate actually. Now, I don't know if you know, here I have a set of standard set of chisels. These are Japanese chisels, so they look bit different from the ones we are used to. I'll do the same. So this is the thinnest one. It's 3. One step up, it's 6. I think the number 9 must be somewhere. One step more. This is 12. And you guessed it, this is 18. I can go a bit further, and you already know this is 24, and this is 30. So this actually the same numbers. You can check this. So this is the smallest one, or the narrowest one. It should be the same thickness as this board, and it is. Then I was missing number 9. So the next up is number 12, or 12 millimeters, and there you go. It's the same thickness. And then standard measurement 18 is exactly the width of this chisel. So probably there is a logic to this, and actually there is, and it has to do with measurements of your body action. These measurements are from the period before we had the metric system. So we still had something similar to the imperial system of feet and inches. And these measurements, think of it, if I start with 24, and I would say 24 equals 1 unit, then 18 is 3/4 of 24. So this width is 3/4. This one, 12 millimeters, is just a half. 6 millimeters is a quarter. 3 millimeters is 1/8. And then, if you think of it, if you have to make things, calculating becomes much more simple. So we have 1 3/4 of an inch, half an inch, a quarter, an eighth. And then, if you think of it, if the boards you have readily available have the same thicknesses. For example, I have a chisel which is exactly the thickness of the material I already have. And this is making life much easier if you have to make things. For example, a mortise and tenon joint, so a hole and a pen. If I have a chisel which has the thickness of the tenon I'm already making, I don't have to measure anymore. So I would have material, let's see, of half a unit, half an inch in this case, 12 millimeters, and I have a chisel. This is especially a mortise, a very heavy chisel, mortise chisel for chopping mortises. If I have a chisel which is exactly the same thickness, I don't have to measure, and I don't have to adjust the sizes of the things I make. So these measurements and these inches are actually, let's say, it's much more logical if you're making things which are, let's say, about the size or have to do with the size a human body is using. And then inches, feet and inches. In the word feet, you already recognize a part of your body. In Dutch, feet and inches were voeten en duimen. And duim in English is the thumb. Remember, this one was let's say the standard unit, 24 millimeters, which is a strange number. But apparently it has to do, it's related to your thumb, and it's related to your thumb in this way. So the standard unit is actually the width of my thumb. And if I would want to measure a board in smaller units, I can just measure like this. So I now know this is about 6 inches. Think of it, if you get used to the system, actually 6 inches for a distance like this is easier than 150 millimeters. a set of chisels like this is available has to do with this standard system. And it was, let's say, everywhere. So in all other tools, you had the same thing. These are called shoulder planes, and you see they come in a variety of width. And here again the same. This is 18 millimeters. Again, strange measurement. But if I check, indeed, it's the same thickness. So this was three quarter units, 3/4 of an inch, and it corresponds to one of the chisels I have. So actually, these millimeters are, I think, more confusing, but maybe it also belongs to a world which has changed from doing work with your hand to a lot of machine work. So in that sense, it might make sense. Just to show you, here is again one standard set of chisels, which you still can buy, and here I show the fractions beneath the chisels. So you see the standard set, and there are other tools too. Here is a set of rebate planes. For example, they also came in these sets of standard width, and boards, not only plywood but also solid wood, also came in these kind of thicknesses. Let's go to whole sheets of boards, and then I have to go away to get one. Just a moment. Okay, I got some boards just to check, and let's see if this system also relates to these boards. This is 1/4 of a standard size plywood panel. Behind me, I only have a narrow one, which has the correct length. So let's see if I measure this, what kind of dimensions I get. The width is 61, and you guessed it, the length is 122 centimeters. Here we are again. It's, again, strange dimensions, but these are standard dimensions. So the question is, where do they come from? If this is 1/4 of a board, and I would have 4 of these in length, then it's a complete board. What would be 122 in width, and it should be 244 centimeters in length. Let me check. And now, of course, I prepared, and I knew it was 2 meters 44. But here's the same question: where do these numbers come from? We talked about inches already. So the inch is derived from the width of your thumb. Maybe these measurements of these standard boards also are derived from measurements of your body. I already talked about feet and inches, so let's check if maybe feet have something to do with it. And then I should somehow be able to demonstrate this. Maybe you believe me if I, let's say, measure like you did when you were a small boy, when you were playing soccer, or a small girl. You could measure with your feet. You can measure things with your feet. And then if you do measure this, for an adult person, a foot is more or less 30 centimeters. Or might it be, if this is 61, this could be 2 feet. So 1 foot would be about 30.5 centimeters. And indeed, it is. So this is, it's at the same time, it's 61 by 122 centimeters, but it's also 2 by 4 feet. And 2 by 4 is, of course, much easier than 122 by 61. And if this is 2 by 4, and the whole panel would be 4 by 8. So again, it's for the ease of calculations, and it would make life much more simple, and that's where these measurements come from. Here's an example where we can see this again, and this is a price list of plywood panels, plywood boards. It's a price list in Dutch, as you can see. We see that the sizes of the smaller ones, which are on the upper side of the page, are 153 centimeters square. Again, here we have a strange number, 1.53. But if you do it in inches or in feet, actually it makes a lot of sense. It's actually 60 by 60 inches or 5 by 5 feet. Here we see it again. It's much more simple. And the thicknesses you see 3, 4, 6, 9, 12, 15 and 18 millimeters. If we express this in the units of inches, again we arrive at these simple fractions. The bigger sheets, the bigger boards like I just showed, here are, well, they are a bit different, but let's say the standard sizes are 2.44 by 1.22. Like I said, this is 8 by 4 feet, or if you express it in inches, 96 by 48 inches. And here again, the thicknesses, of course, also are these units again. And here you also recognize 24 millimeters, which would equal an inch, and 30 millimeters, the thickness of my widest chisel, remember, or of the heaviest shoulder plane I showed, is 1.25. I tell you all these things just for you to realize that measurements have to do with, well, using things and measurements of your material. It's related to the size of a human body and how you handle this design. That was it for now for the workshop. Let's get back to the living room. Now it's in the West, we are not the only ones who measure with parts of your body, which makes a lot of sense. This is a drawing of the system of measurements in Japan. It's the traditional Japanese measurements, which, as you can see, are also derived from body parts. A foot in Japan is 1 shaku. They also use the span of your hand and the width of your hand, but also, like we did, the measurement of 1 step. And in this picture, you see these 3 systems of measurements compared. So at the bottom, you see our metric system, meters and millimeters, compared to feet and inches, and at the top of the page, the Japanese system of shaku, which is 1 foot, which is related to sun, to the measurements of sun and measurements of ken. So you see, well, the Japanese system and the imperial system are related, but not so much the metric system. So I talked about the dimensions of materials. If you go to architecture, the same thing is actually happening. This is a picture of a part of historical Amsterdam. And you see that except for this church, all houses are more or less the same size. Let's say the unit of measurement of the houses is almost the same everywhere, and you can say this is related to the way these houses were built. The floors span from the walls between the houses, and to build this in an economical way, you need timber beams, or in these times you had timber beams for floors, and these had an economical size, which was about, well, it's between 5 and 7 meters, on average 6 meters. So all these houses are more or less 6 meters wide, just because it was the length of the available building material for the floors. So you can recognize the dimensional aspects or the dimensional features of materials also on this architectural or even urban scale. Okay, let's go to the next subject. What you see here are the utensils for a traditional Japanese tea ceremony. These are the tools you need for a tea ceremony. And you see these utensils here are placed on the floor. You have to know it's a floor, but they're on the floor. And here is a picture, a wood block print of such a tea ceremony. And you see these ladies sitting on the floor. Here again. So actually you can see this ceremony is taking place on the floor. And on a special floor, it's a floor of tatami mats, so mats of rice straw, also filled with rice straw, if I'm not mistaken. These floors are soft, and you have to be very careful. So you shouldn't walk on it with your shoes on, because they're too vulnerable. And here you see a collection of these kind of mats making up spaces. A tea ceremony pavilion, actually. And these mats have their own determined sizes. They're all the same size, about 90 centimeters wide, 180 long. So sizes of rooms are actually determined by the amount of mats. So you have a 3-mat room, a 4.5 mat room, 6-mat room, and so on. In this system, you could tell a carpenter you want him to build you a house with a 6-mat room, an 8-mat room, a 3.5-mat room, or a 3-mat room, and so on. And this would be more or less enough for a carpenter to know what he had to build. So actually no design, let alone an architect, was necessary. Even the height of the ceilings, I always like this idea, the height in the system, the height of the ceilings was related to the size of the room. So an 8-mat room gets a higher ceiling than a 4-mat room, for example. So even this, the carpenter even knew how high he had to make the ceiling of each of the spaces. And this way of building, or the starting from the unit of these mats, 90 by 180 centimeters, brings with it a specific kind of architecture of rooms bunched like you see here. Let's say it almost naturally brings along an irregular composition of the floor plans. Now this 1 meter 80 by 90 centimeters, remember, if you would translate this into feet, would be 3 feet by 6 feet. Or remember Napoleon, he was 1 meter 62, or maybe a bit taller. He would, if he would lie down on one of these mats, this would perfectly suit the size of his body. So for a person lying down, 180 would fit perfectly. For one person sitting, half a mat would be good. So the size of these mats are related again to the size of the human body. Let's say, I think among you there are many people who are longer than 1 meter 80. So maybe nowadays this has become a bit different. But the system of mats is related to the human body. Like I said, this system makes for a certain kind of composition of floor plans. And in elevations and in building mass, you see this irregularity again. This is a picture of Katsura Villa in Kyoto. with a fantastic garden around it. And in this garden are, I think, in total 4 pavilions for tea ceremonies. This is a bit of a sidestep. The space for tea ceremony, or one of the most famous ones, looks like this from the inside. Let's go back to Amsterdam. If you would have to design in this space in the city, for example, these measurements could very well give you clues for your own design. So if you would have to design here, you could use the measurements or the dimensions you find in the context to use for your own design. This could be an example of how you can use the context as a starting point. This is another example. This is a facade of the Basilica in Vicenza by the Palladio. It looks like a very regular facade. If you look at the floor plans, you actually see that the floor plan is skewed a bit, so it's not rectangular but skewed, which also means that the columns are actually not on regular intervals, but they change. So again, but the Palladio in this case had to fit his own design to the already existing structure, medieval structure, where he only had to put a facade around. So this is an example of how to derive dimensions, modules, greater distances from the context. So I've been talking about materials, I've been talking about use and the human scale, and I've been talking about the context. This is the floor plan of the Katsura Villa in Kyoto. This is an example of using a system of measurements to design. Maybe this one is another one. It's a Burgerweeshuis in Amsterdam by Dutch architect Aldo van Eyck. Here you see small vaults and big vaults, but here there's a very clear building unit again, which is added to a whole system for this building. Actually, also the courtyards, the size of the courtyards are also determined by the sizes of the smaller unit with one vault. The bigger units are 9 smaller ones, as you can see. You're going to start with your designs, and we ask you to do this in models, in physical models. 1 to 100 on a base of 30 by 30 centimeters. I'll give you some examples of what these models could look like. We ask you to do sketch models, improvised models, so don't make them too neat. But they could look like this, for example. This is an artwork by a Belgian artist, John van Oers. It could be something like this, a project by Anne Holtrop. This looks very simple. Something fragile like this, Yunya Ishigami, Japanese architect. It could explore already stability or how you achieve stability. These are by Swiss architect Christian Keretz. I'm showing a lot of rectangular models. Doesn't necessarily need to be like this, of course. You can go curvy. Some more improvise, use cardboard or wooden sticks if you have them, or any other material you have at hand. We started with the drawing by John Germeling of Napoleon. I'd like to end with another project of John Germeling. where you also can see that he makes a bit of a sketchy, almost messy model, and this is exactly, I think, how you could approach the start of this project. Thank you.